All right, I'm going to go ahead and get going here on the Microsoft Azure IoT Developer Specialty Az-220 exam cram. My name is Brian, and I'll introduce myself here formally in a minute. What we're going to do today is we're going to do a quick overview of the Az-220, and we will look at the exam requirements and a few demos and a lot of information about where to look for things and more stuff to study in the future. So before we get going, I'll do a quick introduction of who I am just to kind of give you an overview. Then we're going to take a little bit of time to do the exam overview where we'll talk about the different pieces of the exam. We'll look at, excuse me, look at the IoT solution infrastructure, provisioning and managing devices, IoT edge, managing data, processing data, monitoring, security, business integration, and then I'll finish up with a few other places I'll point you to look into more material on reviewing the Az-220 material. Now, before I dive in deeper, I want to let you know that this is a brief, high-level look at the tools, technologies, and concepts you'll want to be in command of when you sit for the Az-220 exam, but this is in no way intended to be a comprehensive preparation for the test. So what we're trying to do here is just present the test itself, the material that's required, a few concepts around that, and just kind of a high-level overview. But it is in no way deep enough for you to gain the skills that you need to pass the exam. But it should help you get your feet wet if you're just starting out, or if you're reviewing for the exam, just kind of watching through this to hopefully solidify a few concepts, as well as maybe point out one or two places where you might need to spend just a little bit more time cramming before you go and sit for the exam. So hopefully you'll find this useful and interesting. And you know, this exam is aimed at Azure developers. So if you're not a developer, a lot of the material within the IoT ecosystem does revolve around writing code, but the exam specifically has a lot of code stuff in it as well. This is a developer specialty. So you just need to keep that in mind. However, you may still be interested in this material even outside of the code, especially in this. We're not going to dive too deep into code at all today, just to get an overview of the ecosystem and how some of the moving pieces work. So this is me. I'm Brian. I'd love it if you'd follow me on Twitter at BL Gorman, or on LinkedIn. Go ahead and connect with me, linkedin.com and Brian L. Gorman. And you can find me either place. I'm pretty active on both. And you can see here that I have a few certifications, 7 times Azure, and then the MCSD for 3 years, the MCT for 3 years, excuse me, and an MCSD that I had gotten prior to getting role-based Azure stuff. I also recently released a book with A-Press called Practical Entity Framework, but just as an FYI on that, the second edition is currently in edit, and I am working through some of the final editing for that, which that should be out later this year, which is Practical Entity Framework designed for EF Core 5. So the first book is EF 6 and EF Core 3.1, and the second book is EF Core 5. Now, both books are equally valid and will still be valid for a long time, and most of the concepts within Entity Framework are good. So if you want to support me, pick up a copy of that, love it. But if you don't, that's cool too. So experience that I've also have, I have years of development, up to 20 years of development here. I basically started with .NET when it came out in beta in 2001. I was writing VB6, and then I did VB.NET, and then I moved into C#.NET, which was my favorite syntax. I had been studying C++ in college, and so C# was a lot better syntax than VB6 or VB.NET. But I loved all the languages. It's always fun to program. So I earned a bachelor's degree in computer science from Iowa State, a master's in computer information systems from the University of Phoenix. And yeah, so you can see that I've also done some teaching as well at the university level for Franklin University. So basically, if you are here to take this exam, or if you're watching on replay, it is likely that you are someone that at least has a minimal level of experience with Azure. You've been developing in some major tech stack for at least a couple of years or more, and you've likely been exposed to the Azure 204 exam, maybe even have passed that exam to this point. Basically, this is a developer-centric exam. The AZ-204 is the developer associate exam, and if you've passed the AZ-204, I think you'll find the AZ-220 quite a bit easier. If you've not passed the AZ-204, the AZ-220 will have a lot of concepts in it that you would have had to have known, kind of inherent and expected, such as how to work with an event grid, maybe even how to work with service bus, or potentially do messaging or whatever it might be in a storage queue, or potentially even Cosmos. And so some of the things that are covered in AZ-204 cross over very well into AZ-220, but AZ-220 does live in its own ecosystem with the IoT-centric pieces of it. So when you're looking to take a test, usually you want to get that certification to prove your skills, to validate yourself as a potential employee in the field. And so it's a really good idea to make sure that you've mastered the material and that you're prepared to present, that you're prepared to be able to prove that you are worthy of passing the exam. So having the knowledge of the ecosystem of Azure outside of AZ-220 is fairly important, is where I want to go with that. Now, all that being said, there really isn't a magic level, and I've said this on all of my walkthroughs, and I'll say it on this one too. There really isn't a magic level of readiness for any exam. And so you might be a developer who just started, and you might be ready to pass this exam, especially if you're working with this stuff daily, because this stuff is fairly straightforward. It is fairly useful. It's extremely fun, and I think you'll enjoy it as well. Excuse me. And so, yeah, so you may be just starting out and you might be ready to pass this exam, or maybe you've even been working with .NET or whatever like me for about 20 years and you're just like, I'm not sure what IoT even means. And so if you're in that place, then you have a little bit of learning to do, but still, eventually with a little bit of practice and walking through a few labs and such, you should probably be ready to take this exam as well. So again, I'm taking you through a tour of the technologies from the top down a little bit. We'll dive in pretty heavy at first with some demos, and then we'll just do some concept talk towards the end, because there's just no way to do all the things we need to do. But I'll point out things along the way that I believe are interesting enough, that are interesting, but actually important enough that you should spend some more time diving into those details. So before we do that, just a couple other things. As a learning provider for Microsoft, or learning partner, SkillMeUp does offer, training. And so this isn't really a sales call. We're not really trying to get you to, have to take these things, but I want to make sure that you know that if you do sign up to take an AZ-220 with us, you do get 6 months of access to all of our labs. That's the entire SkillMeUp Academy. That's not just AZ-220, that's AZ-104, AZ-303, AZ-304, AZ-204, AZ-500. And we're even doing stuff now in the new security stuff. So joining our academy through this gives you extra benefits, not just associated with this specific test. Also, you'll get an exam voucher, a practice test, and you'll have unlimited real-time labs for those 6 months. The package also comes with 4 days of training in the AZ-220. The Microsoft official course is a 4-day course. And so you can check our schedule, skillmeup.com/schedule, if you want to join any of our upcoming AZ-220 events. So we'll spend a little time now just talking about the exam in general. And one thing I want to do before I go into this is the same thing I do on all of my exam crams. I just want to point out a couple of quick hints for taking exams. When you get to these, you're going to see there's documents. So the docs.microsoft.com certifications exams AZ-220 will have a download with all of this stuff on it. I would recommend you go there no matter when you're watching this, because it gets updated frequently. I believe it's being updated even Thursday. So 2 days from the day I'm giving this, it's going to be updated to implement some new stuff on these digital twins. This should be the new version. Looks like my percentages are off on this slide, so that's neat. No, the 5 to 10 on the business is right. Okay, so it looks like most of them are 10 to 15% here, and a couple 15 to 20. So that does look right now that I'm looking at it again. But you have different sections here, but again, you can go out and get the download and it'll have all that stuff on it for you to read through in more detail what each section entails, as well as, the weighting and such. So use that weighting to plan your strategy. So is there an area that you're weak in that's also prevalent? So maybe you've never provisioned and managed devices in Azure IoT. Well, that's 15 to 20% of the exam, and a lot of the stuff that we're doing today is going to be around that as well. So maybe that's a good place to start. If you are fairly familiar with the business integration, such as Power BI, maybe you don't have to spend a lot of time there because it's only 5 to 10%. And if you're already fairly familiar with it, you're not going to move the needle very high. So it's a lot easier to move that needle if you broaden your knowledge rather than become an expert in one of the areas. So again, just keep in mind as you're studying, if you're really good with monitoring, troubleshooting, and optimizing IoT solutions or any solutions using Azure Monitor, Application Insights, all of the underlying tools that we've used, Security Center for the security, those tools are prevalent in all of the Azure ecosystem. So if you're already fairly familiar with those, it's a really good idea to review the material around what it would do for IoT and how you might specifically push a security module out to an IoT edge device. That'd be important. But other than that, you've probably already covered most of that. So you could spend more of your time just looking at solution infrastructure, maybe even spend a little time on IoT Central just to play around there too. So when you go to sit for the exam, you're going to have about 150 minutes total, with 120 minutes of that roughly to be for the exam. I believe it's about 2 hours that you sit, and about 30 minutes of review, feedback, and reviewing your score. Providing, they always ask you the first few questions, like how do you feel about, they'll rate yourself on a scale of 1 to 5 on setting up the IoT solution infrastructure. Are you, have you done this before? Have you done this with help? Can you do it by yourself? So that, they spend about 5-10 minutes getting that information for for their back end kind of like metrics. So if someone says they're really good at security and then bombs the security section, maybe they'll look to see if the security part's too hard. I don't know. I don't know what they do with it. I'm speculating. But it's a good idea to fill that out honestly. And just, I do not believe it affects what the questions are that are given you, but I could be wrong about that too. So I'd like to believe that they're not going to use that against you by changing the test to give you the things you're the weakest at. But I can't guarantee they wouldn't. I just don't know how they use those questions when you're doing that. So you'll have about 40 to 60 questions on typical exam at Azure for any exam really. They're you can't guarantee the questions because there's no exam that's the same as the other. And there may be, specific parts of the exam that weight higher in the certain version of the exam. So you might have things like multiple choice questions where in some you just selecting one answer, but in other you might be selecting 3 answers. And so one question might actually be worth more points just based on what they offer in the question. So multiple choice may be, 1 or more. You may be presented with situations where you have to do one thing and then you order it as well. So they give you, a list of code or whatever, and you fill in the blanks with code samples that are given as provided in order. It may be CLI commands or PowerShell commands that you may have to understand which is the right one to do. So it's a good idea to always be in command of the CLI and the PowerShell commands around the ecosystem you're testing on, just to make sure that you're able to recognize a good command versus a bad command, not necessarily memorizing what the commands are, but just, if it's AZ create group versus AZ group create, know which one is the correct way to order the words, right? And so just kind of being familiar with that by having done a lot of work with the CLI should help you on the exam. You may choose answers, place them in code. You may be ordering, you may be dragging and dropping, you may be selecting the best solution. So that doesn't rule out the fact that all of the answers might be right, but one of them is better than the other. Then there's generally some sort of business use case, and there's usually some of these one-time only questions. And I love to tell this story every time because, just in case you've never heard one of my other talks, I want to share my failure with you to let you know to help prevent you from failing. So I was taking the 487, I think it was. It was either 486 or 47. I think it was the 487. It was way back when I was taking for the MCSD stuff. And I'd never seen these questions before, these one-time only questions. And it presents a question with a scenario, and it says something like, in order to do this, we'll give you a solution, and you tell us whether or not it works, yes or no. Is this going to solve the problem, yes or no? Or, does this look good? Whatever it is, it's usually a yes or no question. Now, the trick is that they're one time only. And I get why they do this because, of course, if you see an answer later that says, oh, this is obviously the answer, the other one wasn't, you could go back and change it and do better. Well, this doesn't allow you to do that. Not only that, however, the question might change on you. And so I'm taking the test, and I read the question, and then I answer, read the solution, yes or no, read the solution, yes or no, read the solution, yes or no. So the first three, I was determining whether or not I was yes or no. And then the next one came along, and I'm like, this doesn't make any sense. I think I put no. And then the next one came along, this doesn't even make sense at all. And then I realized they'd changed the question. So just make sure if you're getting these one-time only questions, make sure before you answer yes or no that you've reviewed the question, that it hasn't changed on you. That's my biggest hint to make sure that you're not gonna, fail like I did on that one. So I ended up still passing the exam, but it was hairy to say the least, because I was like, whoa, I think I just failed the exam already and it just started. But it didn't quite work out that way. I was all right. So. All right, so diving in a little bit more to the IoT ecosystem here, what you see is generally what we're going to have is three areas. And a lot of the images I'm taking today are directly from Microsoft. So I generally put the link on the bottom, and I hope that that's good enough for anybody who, wants to be academic about plagiarism. I'm not trying to plagiarize. I just don't want to recreate the wheel. And all of these images and documents, things that I'm presenting today, you're going to be able to find at Azure. And so I'll generally put the link there on the bottom. If anybody's watching this back and you're like, I really want that link, I didn't see it in the slide or something, reach out to me. Twitter, email, bgorman@skillmeup.com, or no, excuse me, bgorman@appsagility.com. Twitter, blgorman, or hit me up on LinkedIn, and we can, and I'll get you links to anything I found here. I'll find it for you again if I have to. But in the IoT ecosystem, we have things, insights, and actions. And so these are the main things that are going to break down. The things are going to be our devices. The insights are going to be our Azure services that we're going to use to build out solutions. And the actions are going to be things people do with that information. So, we might have a bunch of sensors in a building. That's a physical object or things such as industrial equipment, devices, sensors that connect to the cloud either persistently or intermittently. They may be an edge device. They may have an edge gateway that they connect through. There may be edge modules running out there. So that we'll talk about that as we go a little bit, but those things are basically gathering the data and sending the telemetry. Our insights then come when we get into the hub. So we're going to get all this information coming into our IoT hub. The IoT hub is going to be the gateway, the main gateway for information from our edge and IoT devices both into our Azure ecosystem. That IoT hub is going to be our basic landing spot, and all of the telemetry will come there. And from there, we may run stream analytics on it. We may process it into storage. We may do other things with that data at that point that causes us to be able to then present that information in a meaningful way to our users. And then those users can make decisions. Do we want to, stop the line in the factory because the vibration has gotten too big? Or do we need to turn our trucks around because they're going in the wrong direction, or their ice cream is melting, or whatever they're carrying is melting because the refrigerator is not working? Or send them to a place where they can get the refrigerator repaired so that the materials inside the truck don't get too hot. So all of that information that we're gathering from our things, processed at our Azure services, presented to our users in some sort of business format. That might be a time series insight, it might be Power BI, it might be just an Azure dashboard, something that they can look at and make a meaningful decision and take appropriate action. That's our job as an IoT developer. And it sounds a little mundane, but it's actually quite exciting if you think about it. There's all this information coming in, and you're going to be able to filter it and make good decisions because we're going to write the tools for these people to help them do their job correctly. Excuse me. So again, the insights are just going to be the information collected by the things, analyzed and turned into actionable knowledge. And the actions then are the way that people respond to those, as well as the systems and tools that they use, like Power BI or time, Azure Time Insights and things like that. So again, this is also off of the main page, the IoT products. These are our main areas of concern that you'll want to be fairly familiar with. The new ones here, really these Azure Digital Twins and Azure Sphere are fairly new. Azure Sphere has actually been around for a while, but the Digital Twins is new to the test anyway. And so this is something that I want to just kind of talk about right away. A digital twin. So when I first started reading about IoT Edge and IoT devices, I was looking at this and they kept talking about these twins. And I was like, what does that mean? Does that mean I have a device that's connected out in the real world and I have some other device that it's a twin that maybe it's for redundancy, or is it a twin at Azure that's pretending to be that device so that I can test? What does that even mean? Well, what it comes down to is an Azure digital twin, or a digital twin is really just a JSON file. And that JSON file is really just configuration and information about the IoT device. And it's a twin because it basically allows us to interact with that device directly. So every device that we have out there can have a digital twin. And the digital twin has two main sections: properties that are desired and properties that are reported. Now there's other things that are going to be on there, and as you get into IoT Edge, you'll have modules and different configurations that you can push to your edge devices as well. But the digital twin is nothing more than a JSON file. The JSON file is a representation of the IoT device in the real world. And so if I put a sensor in a building and it's measuring temperature and humidity and perhaps, light sensors or something, whether or not the lights are on, I don't know. Whatever this IoT device is doing out there, my JSON file that backs that as a twin on my IoT hub will essentially say, these are the properties that you told me you wanted to have as desired. So maybe you wanted to have a desired temperature setting of 70 degrees Fahrenheit. And maybe you wanted to have a desired humidity of 35% or less or something. Well, what actually happens then is the device is then reporting that information back, and you can compare the reported properties that are coming back versus the desired properties. And so that allows you to see that right there in your digital twin. And in most cases, actually perform actions where you can set properties. So we can say, we want to have you send me metrics every 35 seconds. And you can use that as a desired property for telemetry delay. And then maybe you decide you want to do every 5 minutes. You push it out there. It updates the device. The device is now only sending me telemetry every 5 minutes instead of every 35 seconds. So that digital twin is nothing more than a JSON file that lives on our hub that allows us to interact with the device, comparing the desired and the reported properties. So the IoT hub itself, that's where we're going to connect and manage our different devices. And so even when we use device provisioning service, which we'll see here, and that's not actually on this page, which it probably should be. We have the device provisioning service that we're going to use to provision multiple devices through enrollment groups or individual enrollments. It's kind of our bulk provisioning solution. But if we're just doing one device at a time, we can actually do that right through the IoT hub. Everything ultimately is connected to the IoT hub. And so this is where all of our devices will be registered and provisioned. And by provisioned, we mean registered and it's sending us telemetry. It's actually connected. And it allows us to then take that telemetry and then use that as a stream to go elsewhere. So we'll talk in more detail about this in a little bit, but the IoT hub is based on the event hub. We have time series insight. The time series insights are going to be how we're going to be able to create different views. So we can look at different pieces of information about when the data is coming in. We can use different windows like sliding windows, tumbling windows, hopping windows, and we need to be aware of what each one of those are when we take the exam, and we need to understand which one works for what scenarios. We're not going to talk any more about windows today, but just keep that in mind. Hopping windows, sliding windows, those windows are important, and we need to understand which one to use in which scenarios when we go to take the test. Time series insights is kind of the landing page for building out some of this information. We have IoT Central, which I skipped over. IoT Central is a little bit different. So this is the one area where we kind of move away a little bit from the IoT Hub and the Azure ecosystem. IoT Central is more like, okay, I just want to build an app, and I want to build an app that works with some devices, and I want to do it quickly without having to really know a lot of the underlying details of how things work at Azure. You can start very simply with IoT Central. And so the nice thing about IoT Central is you can start with many of their prefab solutions. So if you just go out to IoT Central, build an app, You can build all kinds of different apps. You can use them free for 7 days and play around with them. And in fact, one of the official labs for this course actually walks you through building that truck simulation where you can issue commands to your devices and have your trucks go out to customers, or where you can have telemetry coming back from the truck as far as what its latitude and longitude is, and is it actually moving or not, and watch it move around on a map. It's pretty fun to play around with. All right, so IoT Edge. This is the second area that I was immediately like, what is an edge? What does it mean? Why do we call some things IoT devices and some things IoT edges or IoT edge devices? What does it even mean? So going back a few years, there was a type of programming that we used to do, and people still do it. I mean, but distributed programming, right? So back in the day, our servers weren't as powerful as they are now. When not everything was web, and so we would send, pieces of programs to other people, and those programs would run on the person's machine, doing a few things, and then ultimately reporting that back to our solution central. And so with that, we would have what we call distributed programming. We basically pushed some of the work out to the other machines. Therefore, our server doesn't get overloaded with so much work. So when we think of an edge device, we can think of it very, very similarly. So an IoT device might be a sensor that you have in the cloud, or a sensor that you have in a building, or sensor on a truck, or any IoT physical device that you have somewhere that's connected to your IoT hub. Now, certain IoT devices can actually be edge devices. And what that means is they've been pre-approved in the Azure ecosystem to actually take modules and run them locally. So the main example that we'll talk about today is we have a general Azure IoT solution. We push a bunch of devices out. Those devices send information back to the IoT hub. That IoT hub then puts a stream analytics job on it and says, okay, I'm going to run through this metrics, these telemetry, the data. I'm going to select the 15 anomalous records that came in from the 1 million that we just got in the last hour, and I'm going to send that information off to the people who need to make decisions. Well, that's great. It works just fine. So if we took all 1 million pieces of information into the IoT hub, and then we sent the 15 that mattered to other people. If we want to build a distributed solution, and this is extremely useful if you have low latency, low internet connectivity in your edge areas. So let's say you have a bunch of devices just that are deployed into the wilderness for some reason, and maybe they have, not necessarily the best wireless internet connections. And so sending every piece of telemetry from them into the Azure hub might not be practical. It might not even work. And so what you can do is, if the device is pre-configured as an edge device, which means that it just has an edge runtime on it, you basically deploy that edge runtime to your device, and now it works as an edge device. You can then build your own custom modules or use pre-built modules and push them out to the device, and thereby do the processing at the edge, and then only send the telemetry that matters to your hub. So in this scenario we had before, we had 1 million devices out there sending in 1 million records per minute or per hour or whatever it is, and then a stream analytics job running at Azure, taking the 15 records that mattered and sending it on. We might have, our devices out in the cloud. We might have some of them deployed in a way that's kind of an edge device, even maybe an edge gateway, and those devices then run the stream analytics job themselves and only send the relative information or the important information back to the IoT hub. So now we've limited the traffic to the IoT hub, which is really good if we've gotten to a situation where we get a 429 for too much, or basically we're throttling our hub because we're sending too much information. Distributing it out to the web, or out to the edge, excuse me, is a great way for us to make sure that we don't end up having too much information coming in. Azure Sphere is a nice security thing. And then the Windows IT and the Azure RTOS, we're just looking at OS support basically for IoT development and embedded devices. All right, so let's move along and let's actually dive into a few things here. So again, some of the major moving pieces we're going to talk about today. Again, just to kind of quickly review, the IoT Hub is the gateway for all device communication into Azure. It's based on Azure Event Hubs. So like Event Hubs, The IoT Hub is designed to process millions of records, has things like partitions and consumer groups, which allow specific solutions to read the stream at will with replayability. And that's incredibly useful for doing analytical reporting and processing. When we do what's called the Lambda architecture, we're going to go both in the warm and the cool paths. We have a hot path where we're sending telemetry directly to our device or from our hub directly to people making decisions or to alerting or whatever it might be right away. And then we have our cool path, which is, we've maybe pushed all of the telemetry data into storage, and now we have people coming back and doing reporting on it. And so the data is still there. It's just not the direct hot path. It's just you go through, we're looking at data from last week rather than 5 minutes ago. So by having the IoT Hub with the different partitions and the ability to do the replays on those different partitions via different consumer groups, one consumer group per reader as per any Azure recommendation, you get that ability to do replayability without a lot of duplication. It's really nice. It gives you the ability to quickly respond to incoming metrics and have the deeper analysis later on. The DPS, or the Device Provisioning Service, is the tool that gives you the ability to do massive device enrollments using enrollment groups. So there are two types of enrollment that we can do with our devices. Directly, we can do symmetric keys, which is just a key pair, kind of like what you would see if you're connecting to Azure Storage. You've got a key that'll let you connect. You can kind of do the same thing to, as an attestation mechanism. Your device can say that I just have the right connection string to connect to the hub or to the DPS through symmetric keys, or you can use X509 certificates, which is probably the way you're going to do it in the real world, to allow devices to tell you that they are who they say they are, that they should be allowed to join your network and send you data. So a couple things to just be aware of on the DPS. Just be aware that as you do bring up millions of records or millions of devices, as you start building enrollment groups and bringing in on your entire system, there are throttling limits on how fast you can actually provision devices. And so let's say you had 1,000 devices that you're trying to provision and you turn them all on at once. You may not see all of them starting to send data for 15, 20 minutes. Because maybe only 100 of them can register per 5 minutes or something. I don't know exactly what the numbers are, but just know that there are limits when you're provisioning your multiple devices. So again, edge modules can be provided by Azure, such as a storage module, a stream analytics module. You can go to the marketplace on Azure and look for any of them. Just look for edge modules and you can hopefully find a list of the ones you're looking for. You then provision the edge module through your solution into your IoT edge device, and that is done again with JSON twins, the module manifest, and all of the different pieces that you need. You'll need to understand all of that when you go to take the exam. You'll need to understand how to deploy a custom edge module that you've written into a container through Azure Container Registry, for example. So just keep all that in mind. There's a lot more than what we're going to do here today when it comes to edge and edge modules. And then again, edge devices can work as a gateway, but in order to get those devices registered, you must have a connection to the internet. So just because I have an edge gateway doesn't mean my devices can connect even if I'm offline. I have to have, for the initial connection, I have to be able to connect back to the hub to do the attestation to authentication piece and make sure that I can be registered into the hub, even if I'm coming through the edge module as a gateway. Processing, however, can happen offline on an edge module, and as long as you have storage or room to store the data, that data will stay there on your edge as long as you need it and you have space. You can then send it to the hub when you're connected. Device module twins are just that digital JSON representation of the devices and modules at the hub. Devices and modules both have twins. For the majority of what you do in the academic learning how to do stuff, you'll be living in the device twin area, but the module twins are also again going to be important, especially when we start talking about edge modules. And so these allow you again to do desired and reported properties. You can also dictate the modules and endpoints and route your messaging for edge devices. So we'll look a little bit at some of the syntax to do that, but we're not going to look in detail today. So just stuff to keep in mind. If you haven't studied that, make sure you do before you go to take the exam. Analytics, monitoring, reporting are always going to be a big piece of anything we do at Azure. Basically, especially in a distributed networking system like this, where we have devices out in the world, we need to be able to create alerts. We need to understand what it means to create an alert at Azure, which again, if you've taken AZ-204 or even AZ-104, or maybe even AZ-900, you've seen, you know, the alerting mechanisms at Azure. It's nothing different for IoT. It's just using the same type of things to raise alerts, action groups, emails, SMS, all the stuff that you've seen before probably. But you do need to know how to do that. So if you've never done it, make sure you've studied it a little bit. You need to also be able to understand in the IoT world that these alerts are going to give us a chance to do things like look at device connected and disconnected events. We might be able to see, you know, if a device is performing as expected. And then there's a couple things with things like the heartbeat pattern, where we're going to try to figure out if a device is actually working, even if it's not sending us telemetry. So just it might send a heartbeat, or you might ping it to get some information to prove it's still online, even if it hasn't sent you telemetry, because telemetry and operation are not always equal to each other. You know, you may be a device that doesn't send any telemetry until it absolutely has to, but that doesn't mean it's not working. But you don't know if it's not working because it's not sending enough information on a regular basis for you to double check. So it's also not feasible. It's just not feasible when you have millions of devices in your system to be able to ping every single one of them over and over and over and over and over and over again to determine if they're alive. So the heartbeat pattern is something you'll want to study a little bit more, just to understand what the recommended way to ensure, that a device that is registered is actually alive, even if it's not sending telemetry. Reporting, again, can also be done with time series insights, Azure dashboards, Power BI, and even other third-party tools like Grafana. They're all out there available to you to use just around the ecosystem. And of course, security. Security is an overarching thing in everything we do at Azure. It's overarching in the IoT system, but it also has some new, unique twists to it in the IoT systems. The IoT security, we need to make sure that we not only have our devices registered and authenticated, or using certificates to do the attestation of who they are, and they should be able to join our network. But now we also have to consider things like, what about bad players? What if we have a device that's in the world and somebody tampers with it? What if it's a camera and somebody covers up the lens? How do we know that this stuff is not happening to prevent, this stuff all comes into play in IoT security. So you need to be able to protect your devices, and you need to be able to detect if the device has been tampered with. So you can use Azure Security Center and other tools to add additional security into your IoT solutions. So the first part of the exam is the IoT solution infrastructure. So we're going to spend the bulk of the rest of our time on just kind of the initial setup of a couple different features with IoT. The IoT hub, the IoT DPS, and just kind of live there. And then we'll finish up later with just kind of an overview of Edge and the other things that are living on top of all of that. All right, so the IoT solution architecture. So for the exam itself, you should have worked with these tools enough to be able to leverage them in your solutions. And if you haven't done enough with it, then you're going to want to make sure that you spend a little time making sure that you've worked with these tools inside of the Azure ecosystem and done enough creating, configuring to be able to troubleshoot, to be able to understand what the moving pieces are, how to tell what's connected and what isn't, what's registered, what isn't, and what the differences are. And so when it comes down to it, the main thing again is going to be our IoT hub. So the IoT hub is going to be the backbone of our entire solution architecture. And so that's the root of everything we do. Devices are registered for connection and then provisioned, which means connected to the IoT hub. Again, once you get a device at the hub, you can have a digital twin. That digital twin allows you to then be able to configure desired or reported and review reported properties. Ultimately, later, as you dive deeper, you learn that you can query those and use those to determine things as well when you're doing things like a stream analytics job. Device twins, again, are going to be the backbone of how you can easily, quickly change some configurations, as well as make sure that your things are reporting, in the desired state. With your IoT Hub, there are a couple different versions. There's a basic tier and a free or standard tier. So as you're developing, you're going to use the free tier most likely, but just know that the free tier doesn't do everything that the standard tier does, mostly when it comes down to throughput. You can't have as many devices connected, and you can't have as much messages per day. So when you go out into the real world for your solutions, you're going to want to switch to the standard tier. Now the basic tier exists, but note here, there's quite a bit of difference in what's offered. And so the basic tier doesn't allow you, for example, to do cloud to device messaging. So two types of messaging: device to cloud, which is the telemetry coming into the IoT Hub, and cloud to device, which is me sending a message out to the device, asking it to do something else. So if I'm using basic, I can't do cloud to device. I can only take telemetry in. You also don't get the twins, you don't get streams, you don't get IoT Edge, and you don't get plug and play. And so the basic tier is great if you just want to set up some basic bunch of devices sending me data as much as possible, and we don't really care about communicating back to it. But the free and standard tier give you that ability to do the two-way communication as well as IoT Edge. So a couple of different things. As a coder, as a developer, there are two different SDKs that we can use, or well, there's multiple SDKs, but the main ones that we're going to have SDKs to work against our devices and SDKs to work against our services. So you're going to want to make sure you keep that separate. The IoT Hub or the event Hub basically has an SDK. The IoT Hub, excuse me a second. Sorry about that. The IoT Hub is built on the Event Hub, so technically you can use the Event Hub SDK in some scenarios, but if you do that, you have to make sure your endpoints are in the Event Hub format. And so once you do that, if you've written code to work against the IoT Hub or against the Event Hub, and your endpoints are Event Hub compatible, then you can use the same code against your IoT Hub. We can use code to do device to communication, device to cloud, and cloud to device communication. We can use code to connect and make sure that we're being able to register devices. And so all of that can be handled through SDKs. And then there's a couple of major things that you need to take away from the physical communications area, which is the protocol. And so as you prepare for the exam, make sure you're aware of three specific protocols: MQTT, AMQP, and HTTPS. And also be aware of the ports they use. MQTT is on port 8883. AMQP is on port 5671, and HTTPS is on port 443. Now, if you're in a scenario where your networking, your firewalls, whatever's been set up by your IoT, by your IT department, doesn't allow anything over any port other than port 443, you can use all three protocols on port 443 with WebSockets on MQTT and AMQP. So as long as you implement the WebSockets, you'll have the ability to communicate on 443. Now, additionally, each one of these is for specific or has specific things that they can and can't do. We'll cover them in a little more detail in a moment. The important things to take away from this. So if I'm using cloud to device, for example, the HTTPS protocol cannot do a server push. So if I'm using HTTPS, all of my devices would have to pull for cloud to device messages, and that can be a huge performance issue. So you should only do that if your device is rarely connected. Otherwise, you should use MQTT or AMQP because both of them support push for cloud to device. If you have MQTT or HTTPS, only one device per TLS connection is allowed, so you can't do connection multiplexing on those two protocols. So if you want to send a single message to multiple devices, such as a pool of devices, you would use AMQP. And MQTT and HTTPS are smaller as far as their resource footprint, so they have less demand on your solutions than an AMQP demand would be. So if your physical device has less than 1 megabyte of RAM, for example, you may be forced to use one of those rather than AMQP. So just keep that in mind. You need to be aware of some of the different scenarios and limitations. Again, all of them can communicate over 443 if necessary, allowing you to communicate through network firewalls. And the last piece of information that I have for you on this today is that the HTTPS will use, plain text or encrypted over SSL or whatever messaging, whereas MQTT and AMQP will use binary messages. So just keep that in mind. All right, so what I'd like to do now is actually create an IoT hub. So we can finally do some actual physical demos. That's a lot of talking. If you've watched any of my other talks, or if you know me from anything else, you know that I'm much more practical than informational. So I like to see it to get it solidified. So what I wanted to do was just walk you through some of the CLI commands today to actually create and work with an IoT hub. Now I have one out there that I've already pre-configured so that if stuff goes horribly wrong on one of the demos for later, we can recover. If you've watched any of my demos, you know that something inevitably always goes wrong as well. So let's go ahead and get started here. So the first thing to be aware of is that in the CLI, I'm on the CLI and my Azure subscription in the Cloud Shell. And basically we need to make sure that we have the IoT extension. So if you don't have that, AZ extension add name Azure IoT. That brings in the extension and allows me to do IoT commands. Now I'm going to do some quick variables here for a resource group name of Az-220 IoT-EC, and the location is East US, and my hub name is going to be Az-220 Demo Hub with the date, which is 2021-04-20, and BLG is my initial. So nothing spectacular there. That's kind of the, the easy way to make a unique hub name. Of course, just like anything else, Azure resources that are publicly exposed have to be unique, so it will have its own unique endpoint that way. If you want, you can always echo these. This is in Bash, so I'm a much bigger fan of Bash than I am of PowerShell for whatever reason, but it's very similar. PowerShell, you would just put $signs in front of these, no big deal, right? All right, so again, just quick commands. We're going to create a resource group here. So here we're AZ group create location and resource group name. And so this should take about 10 seconds. And there it is, it's created. If we looked, and I'm sure it would show up there, but you'd see that it's AZ-220 IoT-EC is now available. And it may take a minute to show up in this screen up here. And I didn't mean to export that. But ultimately, it'll be up there eventually. We know it's there. I'm not super worried about that. Now let's create the IoT hub. So a couple of things about the IoT hub. I'm going to go ahead and create this one first. This is going to create it with the hub name that I gave it as a variable, the resource group name, and the SKU is going to be standard 1. So this is a standard hub. The standard hub by default has 4 partitions. So if you're all familiar with event hubs, they have up to 32 partitions. A standard IoT hub has 4 partitions by default. And so again, the reason you're using partitions is to create consumer groups so that you can have different people reading. If you have more than 4 on an IoT solution, you could probably do that. 4 is pretty much the standard. Now, if you do the free, however, the free one, let me just show you this command real quick. So the free one is going to require you to basically tell it how many partitions you have. And so here, if I wanted to do the free, I would do the same thing I did before, AZ IoT hub create with a name, hub name, and then the resource group name. The SKU is F1, but the partition count is 2. And if you don't put that on there, it won't create the free version. So free has 2 partitions, standard has 4. Not a big deal. Not even sure if that's important for the exam or not. Definitely important as you start developing and working with solutions in the real world. So it takes a moment to create an IoT hub, and that will take a moment to get done. So that's going to be the end of the demo anyway. So let's go ahead and move back to the talk for a second, and when we get done, we can come back here and look at the IoT hub in a little more detail. So the next thing that we're going to do is we're going to start. Oh, I wanted to cover also that we have a lab available. So if you join our Scale Me Up Academy, one of the labs that we have is called Getting Started with Azure IoT Services, and it has both the IoT hub and the DPS. You provision one of each, and then you read through a bunch of material about all the different features on both of them. So it's a really good way to get a good overview of the IoT hub and the device provisioning service. So the next piece of the puzzle, outside of knowing what the IoT hub does, is going to be provisioning and managing devices. So these two pieces make up about anywhere from 30 to 40% of the exam. A pretty big chunk of the exam is just understanding the ecosystem. And then of course you add the edge into that and you get another 30, another 20% or whatever it is. So in this part, we want to talk about device provisioning services. We can connect devices correctly to the IoT hub. We'll see an example of that in a minute. But we also have the ability to do what we'll call enrollment groups at the device provisioning service. The enrollment group is going to allow us to create a group of devices that we can register through a secure attestation, such as an X509 certificate, which I'm hoping to be able to do a demo on as well yet today. When you create the DPS, you also need to link it to the IoT hub, but just know that the DPS can have multiple IoT hubs that it supports. So you can use the DPS to provision your devices in different scenarios, such as latency or region or whatever you need to do across your solutions. So also we need to be familiar with this process of deprovisioning and auto decommissioning with devices. So as we create enrollment groups, we create the ability to join the IoT hub. So we'll do that through the DPS. You can again join the IoT hub directly, but if you want to use the enrollment group, you're going to go through the DPS. As you go through this, you have a two-piece registration connection process. The same thing goes for a decommissioning process. It's a two-piece thing, and it's very important you understand this. Just deleting the enrollment group does not delete registered devices. So if I have a device connected to my hub through an enrollment group, and I need it to no longer be connected, I need to go to the hub and deregister it, and also delete or disable the enrollment group. Now, individual devices can have their own enrollment processes as well. So an individual enrollment will override an enrollment group. So if I have another piece of the puzzle here, if I have a device that's registered individually, but also is part of an enrollment group, I decommission it from the hub by deleting it off the hub, deregistering it. I turn off the enrollment group. That device can reconnect through its own individual registration because the individual registration will override the group enrollment. So just keep that in mind as well. That two-piece process is extremely important to understand. If I don't do it right, my device will either be able to re-register. So if I just delete the registration from the hub and I leave the enrollment group active, the next time I go to send telemetry, I just reconnect to the hub. So I've done nothing to block that device. If I just turn off the enrollment group, but the device is already connected to the hub, it will continue to send telemetry to the hub. It makes a lot of sense once you see it in action. It makes a lot of sense. You just have to make sure to remember to do both pieces of the puzzle if you want to turn off a device and not allow it to re-register. So the IoT hub has that device registry, which allows us to determine what devices are actually connected. We can then use that to deregister devices. We also can look at the IoT hub to modify device twin tags and properties. We can trigger actions using IoT hub jobs and direct methods from the IoT hub. We can set up automatic device management of the IoT devices at scale using the DPS and enrollment groups. and we can leverage IoT Central as well. So that's part of this piece is the IoT Central, and it's kind of in its own little world. So again, it's part of this piece of the exam, but the IoT Central is really its own world. And so when you go out to the IoT Central, play around with the apps out there, understand how to create templates and interfaces, which is a lot like what the digital twin stuff is now, kind of getting those templates in place to register devices through the IoT Central. And it's a little bit different than the hub and DPS. So when we talk about provisioning, we say you're allowed to connect, and basically you can connect as a single device, you can connect through a group. The different ways you can do that are through the asymmetric keys, X509 certificates, and one thing else is a TPM module. So basically, if you have your hardware security modules and you have a trusted, I can't remember what the P stands for, but basically the TPM allows you to register devices because it's using that trusted secure attestation through that module. So the main ones we're going to talk about today that we'll see a little bit of is the asymmetric keys in X509, but just know there's also TPM as well. And again, just to reiterate this point, devices already registered have to be deregistered even if an enrollment group is disabled in order to stop communicating. So just keep that in mind. It's a two-step process. Device provisioning service itself allows us to have zero-touch provisioning. This means all my devices can connect by attestation either through a certificate or through keys without me having to do anything to connect them to the device to the hub. The DPS again gives us the ability to connect to lowest latency hubs, allows us to re-provision if we have device changes, such as we want to move. Let's say, okay, take this to the next level. We have a device that's deployed in a building in Indiana, and we sell that device to a different part of our corporation, and they're in California. The device gets shipped to California. Now it's connecting in California for whatever reason, and instead of in Indiana, and so we want it to connect to a different hub that's closer to its region that it's in or whatever it is. That reprovisioning can all be done through device provisioning service. It also allows you to roll the asymmetric keys. So when it comes down to provisioning, just remember two things. The first part of provisioning is establishing the initial connection between the device and the IoT solution by registering it. The second part is applying the proper configuration to the device based on specific requirements of the solution it was registered to. Once both of those steps have been completed, we can say the device has been fully provisioned. So some cloud services only provide the first step of the provisioning service, registering devices to the IoT solution endpoint, but do not provide the initial configuration. With DPS, the device provisioning service, you get both steps to provide that seamless provisioning experience for the device. Again, it also gives you the ability to do secure attestation for X509 and TPM-based identities. You can have an enrollment list containing the complete record of devices, groups, and devices that maybe at some point register, even if they're not registered to the hub right now. The enrollment list contains information about the desired configuration of the device once it registered, and it can also be updated at any time. You can have multiple allocation policies, which control how DPS assigns devices to the IoT hubs in support of your scenarios, such as lowest latency, an evenly weighted distribution, which is the default and which is what we'll use in our scenarios today, a static configuration via an enrollment list, and the latency is determined using the same method as Traffic Manager. One other thing I forgot to mention on the other screen, I skipped over it, was that you can use your DPS kind of as a load balancer across your event hubs, across your IoT hubs. You can do monitoring and diagnostic logging to make sure that everything is working properly. Multi-hub support allows you to assign devices to more than one hub. DPS can talk to hubs across multiple Azure subscriptions, so that's important to know as well. It doesn't have to be in the same subscription. You can talk to the hub elsewhere. You can do cross-region. You can assign devices to IoT hubs in other regions. You can use encryption for data at rest, when allowing the DPS to be encrypted and decrypted transparent using the 256-bit AES encryption, and it's FIPS 140-2 compliant. So if you're caring about encryption and you are concerned about what those things are, they're available to you. Yeah. So just like all other Azure IoT services, DPS works cross-platform with a variety of operating systems. Azure offers open source SDKs in a variety of the languages that you would be used to using: Java, C#, JavaScript, Python. Those are all going to likely be available to you. Allows you to facilitate connecting devices and managing your device. DPS supports the following protocols, which again is HTTPS, AMQP, MQTT, and then of course AMQP and MQTT over WebSockets. And the DPS only supports HTTPS connections for service operations. And one thing that we need to also be aware of is these quotas, or are these quotas, excuse me. And so I put a couple up there, and so you can see device provisioning service throttles requests, such as device registrations at 200 per minute. So you can see that if you have 1,000 devices connecting, it's going to take at least 5 minutes, right, to be able to register all those devices. The operations also similar, 200 minutes, 200 per minute. You see the different resource allocations you can do. You can do DPS services per subscription is 10. The number of enrollments is 1 million. Registrations is 1 million. Enrollment groups is 100. You know, CA certificates 25. Linked IoT hubs 50. And maximum message size is 96 kilobytes. If you need to increase any of that, you can reach out to Azure, and all this information is available on Microsoft documentation about IoT DPS. So you can see that link there if you want to read more about all this information. All right, so second demo that I want to do is actually creating a DPS and linking it to the hub. So let's go out here first. Our IoT hub is done. So let's pick up where we left off last time. Let's just take a quick look at the hub itself. So hopefully our new resource group shows up this time. And it's there, and inside there is our hub. So if you're familiar with the hub at all, this isn't going to be rocket science to you. But if it's not, just again, that's a good chance to just do a quick overview. The main moving pieces you want to pay attention to are going to be down here, different messagings that's happening on the hub. And you know, this is obviously picking up telemetry from when I had it deployed earlier, because we just deployed this. So it's funny that it thinks it's getting messages, nothing connected to it right now. All right, but it says 0 here. So IoT devices connected 0, messages used today 0, message quota is 400,000 per day. And you see that's kind of your initial telemetry on the hub. It has the public host name. This is your tier, the number of hub units, and minimum TLS version, which really we probably want 1.2 ultimately, but whatever. And then main pieces over here. So this is where we can do some certificates at the hub level. We're going to do certificates at the DPS level in a minute, but you can do them at the hub level here. You have built-in endpoints. You have different devices and things that you can do as well. So in here, you see this one has 4 partitions. It has the Event Hub compatible name. Remember I said that you can use Event Hub SDKs against this. So just keep that in mind. If you need to run against the Event Hub compatible endpoints, you can do that. So your code that you've written against the Event Hub will work against an IoT hub. And you have IoT devices. This is where we're going to show all the devices that are registered as an IoT device. And we have the IoT Edge, which will show any devices that are registered as an IoT Edge device. And so, and you can create deployments and such up here. We're not going to have time to go deep into IoT Edge today, but there are plenty of resources out there for you to dive deeper on that as you want to. Let's see, file uploading. If you ever want to do file uploading or message routing, you can do that through here as well. So you can see different things. You can set up custom endpoints, and message enrichment happens here as well. And we'll talk briefly about some of that, but not a lot. Again, this is just an overview. We can't go deep into all these concepts. We'd be here for 4 days. So yeah, so that's the hub. So this is kind of the main pieces that we want to be aware of. There's more stuff you can do down here as well. Setting up alerts, all that jazz, just like any other Azure service, your activity log, different tags, anything you want to do, connect to the hub through the shared access policies. Eventually this would become important to you, the different policies. Generally, you're either going to use a service device or an IoT hub owner, which gives you all of those 3. And then of course you have registry, read and write, which is what the hub gets. Each one of those has connection strings or shared access keys. So if I just want to expose that to my SDK, I go over here and grab the key I need for the specific permission policy for the shared access. If you're familiar at all with Azure services and communication from code to Azure, these connection strings shouldn't be rocket science to you either. But if not, generally, if I needed to connect and I pretend I'm the IoT Hub owner to do things against the IoT Hub with my code, I would grab this connection string either through the primary or the secondary key, and then use that, put it in my code, and that would allow me to communicate to the hub as the IoT Hub owner. That becomes important as you start doing your edge devices and you start creating routes where you're going to send telemetry from an edge device to the hub. You might need to connect through a service connection or through the hub owner connection or even a device connection to make sure that you can communicate correctly through your code. All right, so let's do the DPS. So the next thing I want to show is the DPS then. And so again, I'm just going to reset here just in case these aren't saved. They are, but we have our resource group name, our location, our hub name, and now we're going to add a DPS name called Az-220 DPS, same date with my initials on there. So nothing spectacularly fancy either. Again, just the quick check to make sure everything got set correctly. And that's looking good. So then to create a DPS is just going to be AZ-IoT DPS create with the name and the resource group. So note, I have not said anything about the hub yet. DPS is created individually and lives individually from the hub, which makes sense because we know that DPSs can connect to multiple hubs, so having it be directly associated to a specific hub would be a bad thing, right? So as that gets built, we'll end up having that DPS that's created. I have one out there already, so let me just show you that quickly. And that DPS, so we can just kind of go over this, has linked IoT hubs, which we're going to set in a minute, so I'm not going to show that here. This is where we'll do certificates, managing enrollments. We'll do all that in a little bit, just on another demo to see all that in play. And then that's kind of the main pieces. This critical piece over here, the ID scope, and this global device endpoint. You need to be fully aware of what these are if you're a developer. The global device endpoint won't change. It's always global.azuredevices-provisioning.net. So just like if you're a developer, you've kind of already probably memorized, storage is always going to be blob.core.windows.net or whatever it is. And, plus your name, plus your container name. Just be aware if you're an IoT developer, you should be aware of global Azure Devices Provisioning Net. And then also ID scope is going to be unique for each of your DPSs, but this is how you're going to use this in code. So with those pieces of information, sometimes the service endpoint and the global endpoint and the ID scope all together, I can communicate with my DPS in code. I'll also have shared access policies on this as well, which gives me connection strings and such. So if I need to use those, I can do that as well, excuse me. But generally through code, we're going to use this piece of information on all of our code. This is going to uniquely identify the DPS I'm connecting to. And then this is the endpoint, which is also going to be unique just because it's just anything else like Azure Devices Provisioning Net, which is the same ending point there with just my DPS name that I put on top of that. So, all right, so my DPS has been provisioned here into my new resource group. So let's go back here. And this is the Az-220 demo hub we just created. So again, it has its own place and its own, that's the hub, sorry. The DPS we just created here has its own unique ID scope as well. So that's going to be important when I start writing code in order to do stuff against this specific DPS. We'll also add certificates and enrollments here in a minute. So once we have the DPS, we need the hub connection string. So I already showed you before, you can actually get the hub connection string directly by going to the hub and going to the shared access policies, and then let's say service connection string or owner connection string. You can go there and grab that connection string. So if I took that piece and then put it in my code, I could do that. but I can also get it through the Azure CLI. So I want to show you the official way to do it is this way, but the AZ IoT hub show connection string dash name hub key primary. So this is the primary key getting connection string, and it's basically putting that into a variable. But you note that it says the command has been deprecated. So it wants you to switch now from using AZ IoT hub show connection string to AZ IoT hub connection string show. So that will line up more with the actual syntax you would expect from an AZ command. AZ IoT hub connection string show hub name. And that gets the same piece of information. And if I don't put the $, it just echoes what I said. So you see there's my hub, there's my shared access key, the IoT hub owner, and there's so basically the IoT hub owner connection string with that shared access key. So I could have got the same thing directly from the hub as I showed you just a minute ago. Right here, IoT hub owner connection string. This should literally be the same thing, except it has host name. Yeah, host name equals that same exact string. So two different ways to get the same thing. Looks like the shared access key is a little different, but whatever. One might be primary and one might be secondary. I didn't maybe grab the right one. I'm not sure. Anyway, either way, they're both connection strings that are valid. The reason this is important is because I want to connect my DPS. So right now, if I look at my linked IoT hubs, there aren't any. So I could do that here. I can just add it in the portal, just like anything else. I can grab my IoT hub that I want to connect to. And, oh, that might be the X, might be the other, might have been the other hub I was looking at. We want to make sure we connect to the right hub here. And so this is the IoT DPS linked hub create. DPS name is the name of the DPS I just created. The resource group and the connection string was that hub connection string I just pulled down, and the location is the location. So that should not be an equal sign. Hopefully that won't screw things up there. Had an extra equal sign on my script. So hopefully that'll link okay. And if I refresh this now, we see that it is, in fact, connected to the Az-220 demo hub, 2021-0420 BLG. And so, yeah, that was the other one. That's why the keys didn't match. So we've connected to the Az-220 demo hub 2021-0420 BLG. So that's one we wanted to connect to. So we're good to go. So we've now connected our DPS to this IoT hub. So you can add another hub here if you wanted to, connect to the other one as well. Using the IoT hub owner policy, you could do that as well. So again, you could have multiple hub support on a DPS. All right, so another thing that I wanted to show you was I wanted to take a minute to do another demo here for a single device connection into the IoT hub. And so to do this, we're going to connect a single device to our basic IoT hub. The having two hubs here is going to screw with my mind a little bit, but to the Az-220 demo hub, that's the one we want to connect to. So again, just to make sure that I don't screw this up, I have these on my scripts, so I just make sure I have the right thing. So we're going to create a sensor THX1138, and that's going to connect to Az-220 demo hub 2021-0420 BLG. So the first thing we're going to do is we're going to create a device identity at the hub. So this is going to say I can connect. It's not actually going to be connected. And when we look at this, what that'll do is it's going to put a device ID here for THX1138. So let's go ahead and throw that in there and refresh this. And so there it is. Sensor THX1138 is now registered on my IoT hub. It is not connected. It is not sending data. So it's not fully provisioned, but it is registered. And so if we look at our overall IoT hub, we'll still see we're not getting any messages. Well, this was getting messages yesterday when I was testing it on the same name, but as of the last hour, it somehow still thinks it's got there. That's weird. 0 messages. It says it's used 4 messages. Interesting. Oh, likely that's a connection or a registration messages or something, right? But it's not getting any more telemetry at this point. Oh, now we're back to 0. Perfect. Now we're back to 4. Oh, now we're back to 1. What's going on? Yeah. So take that with a grain of salt, right? It's supposed to only be looking at the last hour, but I'm not sure that that's entirely accurate. It says 7:15 p.m., which on this machine is currently 7:30 p.m. So it thinks it's getting device information. Anyway, I digress. So the device connection string, again, has an older, and the only reason I'm showing you both of these is just in case it shows up on the exam. I don't know if it will or won't, but I want you to be aware of both. This is the older way. AZ IoT hub, device identity, show connection string, hub name, device ID. And again, it says, hey, this is going to be removed. So use the new one, which is instead of show connection string, it's connection string show. So same thing, that was just the ones not deprecated. And it shows you the device ID, the shared access key, and the host name. So the host name is the hub, the device ID is your device that you created, that you registered. Whatever you want to call that, that's just something I made up, sort of made up. And then you have your shared access key. And again, if I go out to hub, at any point, we can take a look at these devices. We can look at the device and get the connection string right there as well. And you see that it's essentially the same thing with that shared access key, KGMY, TY, HM, whatever. So that one does map right because I grabbed the right one this time. You can see down here, there's also module IDs and configurations. These are important to see if it's an edge device. You can deploy edge modules to it. If it's a regular device, you can still deploy, I think, a security module to it. So while you still see that here, you can add modules this way. You can do that through this, and that will tell the device that it needs to have that module installed. Additionally, this is also where you're going to get your device twin. So here you see the device twin, which again is just JSON. The device twin here is showing me information about the device itself. And then ultimately, this part here is where we really care about as the programmer, because they have that desired reported state. Right now, there's no telemetry, nothing that we're using to do anything with this. It just says this is desired last updated, this is the reported last updated. So, and its capabilities of IoT Edge false. Oh, one other thing, as I created that device, to make it edge enabled, this is me going crazy. I'm just gonna, let's make a new one. Let's just do sensor THX 1139. And then I should never do anything live. It's just edge enabled, I think. Is true? I don't know. Yep. Okay. So now I created a new device, and let's see what happened here. It didn't take that. It didn't like me. Oh yeah, it did. Of course it did. It's just in a different place. It's in the edge devices, right? All right. So there's my sensor THX 1139. This is now an edge device, and you can do deployments to that edge device. You can create deployments where you can do different packages, different modules. So here, you might add in an IoT Edge module like a stream analytics job. Yeah, I'd have to name it something useful. Sorry, I have to get the image URI. So this is where you would get it from your Azure Container Registry. If it's a custom module you built, you'd have an image URI, or you could get the Azure Marketplace. So I'm not going to go any farther with this today. This is completely off the script that I had written for this talk, but it's important, so let's talk about it. Here I could say, Stream Analytics Edge. Azure Stream Analytics on IoT Edge. So I could grab that. I could create that new module. And then ultimately, once I do that, I will have information that I can use to then put that in my deployment. And once I have that, there's my module twin settings that I can use to do routing. So there's two different types of routing on the edge. You can route from the module or from device to the other devices, or you can go from the gateway or the edge module back to the hub. So I'll show you a couple of routing patterns in a minute, but basically that's where you put that into play, is in that module stuff. Okay, so we went a little bit off script there, but I think that's important. I think it was pretty cool to see some of that. Not in enough detail to be good enough at it for the test, but enough to kind of understand where to get started if you haven't. And all right, so we have our hub, we have a device. Let's actually write some code here to connect to it. So let me see if I can't do this in Visual Studio Code. I may already have this open. Yep. Okay. So here we have our connect device starter code, and we have our CS project. This is .NET Core 3.1, and the program is already written. The code's already here. The important piece of code is going to be this device connection string. So I need that connection string here. So let's go back to where we were earlier. We had this connection string. Let me just grab that and throw that in my code here. And so that's going to allow this device simulator to pretend it's a device connected through the connection string to the IoT hub, and ultimately sending device to cloud messages and sending a temperature alert, and basically then also creating that message and serializing it and putting it to the telemetry. And so the protocol here, let me see where that's at, MQTT. So you see it's using MQTT protocol, and so it's serializing that to binary and sending that on. You have different, this is just a dummy class that's creating random sensor data basically to send telemetry to the hub. So, excuse me. Let's see if I can run this quick. Yeah, it doesn't like me. Okay, let's not do it that way. Let's go ahead and run a terminal. And here we have and now I can see how I can see this project .NET run. So that'll rebuild the project and hopefully we'll start sending telemetry. All right, so now we can look at our hub. And we can see that I should have not done the same name, but you can see now I'm starting to get messages. That makes sense. Now it's starting to look more reasonable. It still doesn't have the right numbers here, but that's a little better. Now you can see data coming in around that telemetry that I'm sending. So creating that connection was very easy to do. In this manner, I just used a connection string connected directly to it from code. This is a simple, quick, easy way to do some testing. Probably not the way you're going to want to do it in the real world for a number of reasons, but you don't want your connection string right here hard coded in your code. You don't want, you probably are going to use different attestation other than just knowing the connection string. And so nice and fun, easy way to connect to the hub. But we want to see a little bit more about connecting to the hub through the DPS. So, all right. So let me see where we're at on our demo. Yeah. So we created our linked hub, and we were able to do that. And we then provisioned the single device to the hub, and we were able to get that connected, get that working. We talked about the connection string. We talked about getting the connection string through the CLI as well, just to kind of see the difference. And so the final real long demo that I have for today is getting the bunch of devices to registered using X509 certificates. So just to be 100% transparent on this, this is not necessarily something that I wrote from scratch. The stuff that I'm going to show you is coming directly from the labs. This is lab 6, the automatically provision IoT devices securely with scale with DPS. So you can see that's out there. This link I'll have at the end of the talk as well for those labs. And so you have the devices out here that we're connecting to, but now we want to do a major rollout where we have people using certificates. So again, I have a fallback on this in case something goes horribly wrong, as I do a lot of steps here. But hopefully we can get it to work, because it's pretty cool when it does, and it's actually kind of fun. Like I said, this is actually, I found the Az-220 test to be a lot more fun than the Az-204, just because it's more devoted to the technology, and working with these IoT devices is actually quite fun. So hopefully you're enjoying it as well. And you'll go deeper. You'll build edge modules, and you'll put them in your own Azure Container Registry and use that to provision and deploy edge modules out to your devices. You're going to want to do that before you take the exam, just so you're familiar with the process and familiar with the steps and things you need to do. So don't take the exam without trying to do something like that. We aren't going to do it today because it takes a long time, and I probably would screw it up anyway. So I don't want you to watch me fumble through all that crap. But let's go ahead and get this simple one done, where it's not so simple, but it's fun. We're going to create a device certificate, and we're going to use that on our DPS to register multiple devices. So here we have our DPS. So we're going to have that handy. And then I want to go ahead and just, again, double check and make sure all my variables are set the way that I want them to be. So I have my resource group, my location, and I'm using East US. And I wanted to call this out. It seems to me like there's certain regions that work better than others. And sometimes, like when I've used Central US, which is kind of my default since I'm in Iowa in the middle of nowhere, Central US is our region. And it seems like sometimes Central US doesn't work for some of this stuff. So I flipped to the East US. It's supposed to be available. I looked at the Azure charts and availability of DPS and all that jazz. It says Central US is available, but it seems like East US just works better. So I've been using that for my demos. All right, so we're going to create a directory here to drop in some certificates. Right now there's nothing in there. We're going to go ahead and run some scripts to curl, and this is just going to get me some certificate generation scripts and the ability to create root certificates and a device intermediate certificate. And that cert gen is just a shell script to generate some certificates. And so all that stuff is available at Azure. You see the GitHub user content, Azure IoT SDK. It's all right there. If you look through the labs later, this is all this code is available. And so I want to make sure that the cert gen is in this folder, and then I'm going to change my execution so I can do that. And then what I'm going to do is create a root and intermediate certificate. Now I wanted to show you this piece of the puzzle because this is pretty basic, but knowing these steps is very important for the exam. So knowing how to walk through and do a device provisioning registration process could be something that, I mean, this whole device provisioning process is really important to understand. So I've created a root certificate. If I look around here, I have this certs folder. If I look into that, I have an Azure IoT test only chain certificate, intermediate certificate, and root certificate. And so we're going to use those. And if you want to learn more about what root, chain, and intermediate mean, definitely read up on that. I'm not going to go into it in detail today here, but it's important for you if you're going to start building certificates and you want to make sure that your root stays secure. You might use the intermediate to generate your leafs to make sure that people don't compromise, blah, blah, blah. You can read up on that on your own. And if I could type the right command, we're back in our certificates directory. So what I'm going to do is I'm going to download the root certificate that I just did. I'm going to download that locally. Now, if I hadn't already been doing this today, once you've downloaded one certificate, the next one seems to hang. There will be a little icon or something that pops up here as you do this on your own that says, hey, would you like to let this site download multiple things? make sure you click that and don't just wait and see nothing happening. All right, so we got our root certificate. So now what I want to do is I want to actually create the certificate on my portal. So here's my DPS, and I'm going to go ahead and add a certificate here under my certificates. And I'm just going to call this certificate, let's see, I'm going to call it root CA certificate. And I'm going to go ahead and select that certificate that I downloaded and drop that in there. And so it's very important now that I use that same root certificate from now on, because it's going to have to be used to generate leaf certificates for my devices to register with, right? You see that the initial state is unverified. So what I want to do is verify the certificate that I'm the owner, that I prove that I am who I say I am. So I'm going to generate a code. I'm going to take that code. And what I'm going to do with that code is I'm going to create a new certificate. So here what I'm going to do is I'm going to do search in, create verification certificate with that actual code that was just generated from my verification code. That creates a new certificate called verification code cert.pfx. So I'm going to download that. And again, if you're doing this for the first time, you may not see anything download. You may get a pop-up that says, hey, make sure you just look up here and download, allowed to do multiple downloads. Do not close this while you're in this process. If I close this right now, my verification code is lost forever. I have to restart the process with the new verification code. Just keep that in mind. So now what I'm going to do, so I created a root certificate. I generated a verification code. I used the verification code to generate a new certificate. I uploaded that. I verify it. And once I do that, my root certificate is now verified. And that allows me to then use that to generate other certificates to register devices to allow them to say that they are who they say they are. Okay, so before I do any more with the code, I want to go ahead and set up an enrollment group. So I'm going to open this in a new tab just to get better screen use here. Here you see I have the enrollment group, ability to add an enrollment group. Sorry, I just got pinged a little bit. I want to check something. Okay. All right, we're good. Sorry about that. All right, so here we have an enrollment group, and so my enrollment group name can be whatever I want it to be. I'm just going to go with the lab here, and I believe it was called something like EG certificate group or something. Let me see if I can find it. Yeah. EG test simulated devices. That's what they named it. Okay, and we're going to leave the attestation type to be certificate. The IoT edge device is false in this case. So again, we could use that enabled flag when we register. You can also turn them on true or false generally at the at the registration process. This is a CA certificate. The primary is going to be our root CA certificate that we just verified. There's not going to be a secondary certificate. We're going to use evenly weighted distribution. We only have one hub, so this doesn't matter. But you could see that you could use lowest latency, evenly weighted, which means load balancer, static configuration if you have something set on how to do things, or custom using an Azure function. So we're just going to go with the evenly weighted distribution. Here's our hub that's linked. If you wanted to change the hub here, you could for this enrollment group, whatever you want to do. And we're going to leave reprovision and migrate data as it is. And the final thing we're going to do is we're going to drop a little JSON in here to our device twin. And we're going to add a desired property for telemetry delay. And that just allows us to use that to configure the device itself. And we can disable or enable the enrollment group. So we're going to, of course, leave this enabled, and we will save this. So step one was creating the certificate, getting it validated. So we had to create the certificate, upload it, verify it with the verification code, get the verification code, create a root verification certificate, upload the verification certificate. We have now a verified root certificate. We now created an enrollment group using that root certificate that was verified. Now we're going to put devices in to this enrollment group via certificates. So we need certificates for the devices themselves. So we go back into our code here, and this is just generating really fake certificates with password 1234. So if we actually look at CertGen, we can see that. So that was in certificates, CertGen. So if we look at the code for CertGen here, you can see that the password being used is just 1234. So obviously not a real strong password. That's why they'll warn you not to use this in the real world because it's really bad. So go ahead and close that. All right, so now we need to create some certificates. So let me see if I have the code built for this already. So let's try using our device, create device certificate for sensor THX 1150. So we have CertGen and the create device certificate, and then our sensor name, device ID name. So it created it. Now, before I do anything else, note it created new device cert. So if I go into my folder certs and I do a quick look around, you don't see device, which I called it THX 1150. What you see is new device cert and new device cert for PEM and PFX, whatever you want, the PEM and the PFX files. So that means every time I generate a certificate, I first have to rename those or it will overwrite those. So it's important to keep that in mind. So let's go ahead and rename these. Oops, let's rename these. I missed my code, hold on. I need to go back a level here too. Okay, so we're going to rename those certificates to match the device name, which is THX 1150. I'm going to do two more just for posterity here, so that we have a couple of devices we can connect if we wanted to for 1151 and 1152. And then I'm going to download all three of those certificates so I have them locally. So 1150, 1151, and 1152 are now downloaded. And what I want to do is just quickly show if I wanted to, for my code, I'm going to need the DPS ID scope, which is here in the full DPS information. I also have one more command I pre-wrote to just quickly give me the DPS scope itself. So I need this code when I'm working with my certificates in my code to connect. So I have all three of my sensor certificates, and let's just go ahead and open that folder quickly and grab all three of them. Cut those, I'm on the other screen here, but I'm going to put them into my container device final. So I don't need these ones, so I'm just going to delete those. So here you see I have a container device program with those three certificates at the root of the program. And if we look at that in Visual Studio, we should see now those are my three certificate files. Obviously not displayable, but what's important is I need to change the name of these to THX. And forgive me, I'm not as good with Visual Studio Code as I am with .NET. So this is 1150. Let's just copy this. 51 and 1152. And this is 2 and this is 3. And then I want to make sure in my certificates here that I have device THX 1150. So this is just going to make sure that the files are deployed when you build, just keeping the certificates with the code on the deployment. So all three certificates are going to be deployed into the same project, even though I'm only going to use one of them just to save me a little bit of time. And then this DPS scope, I need to set this correctly to the DPS scope to match my current DPS device, which is that one, to match this down here. And just important again, this is the password for the certificate. So if we changed it, you would change it here. And then global device endpoint, again, you could also store that in secrets, Azure Key Vault, something more useful in the real world. This endpoint is critical. Global Azure Devices Provisioning.net. If you don't have that, it won't work. And that's irregardless of what your hub name or your DPS name is, that's always the same. No, we're going to potentially play around with this telemetry delay. We set the desired configuration of telemetry delay. We have the ability to muck with that a little bit in this code. This code is pre-written. I went through this and made sure I had all the code working. Hopefully it will work fine for our device here as we register it. So let's go ahead and see if we can. So let's .NET build first. I don't want to run it just yet because I want to show you, first of all, I'm done with this. So on the actual DPS, we have that enrollment group. The enrollment group itself is here, e.g. test simulated devices. On the hub itself, we have right now the one device that was connected as an IoT device, which was the THX1138, and then we had an IoT edge that I just randomly did for THX1139. So no other devices connected right now. All right, let's see if this works. So this is where sometimes it goes a little wonky on me. And if so, we'll just default back to the other one quick and show you that it's working. But hopefully I did all the steps correctly. You can see that it's warning me that I haven't used those other two files. I don't care. Let's go ahead and run it. And let's see if it'll actually register and run through the enrollment group. So it found it, it's using it, and it's not provisioning. So maybe I'm just not being patient, but it seems like it's going to hang again on me. So I'm not really sure what I did wrong. Every once in a while, this seems to happen where the device, the same code that should work doesn't work. Maybe I generated the script wrong. Maybe I didn't save something correctly. I'm not sure. But it's hung at this point. It would have already been sending telemetry, and it may be that the other devices are interfering with it. I'm not sure. So I anticipated that I might run into a problem doing this live, so I already pre-built this out. The exact same code, the exact same solution, already done on a second hub, ready to go. So you see it just has a different DPS scope, has the same 3 certificates, but these are the 3 certificates generated specifically with the root certificate for that one certificate. You see this one is device file name 3. This is device file name 2. If I look at the code. And then this one is device file name 1. So they're just using the 3 different certs to connect. Now that one, I already connected to them just to prove it would work to myself. So if we look at that other hub, this is what should have happened on the other one. We have the DPS. The DPS has the managed enrollments. It has the root simulated devices certificate. Everything was set exactly the same. It has that telemetry delay on the device twin, and it has a hub that it's connected to, and the hub it's connected to has currently got 2 devices registered, which if I look at those are the THX 1150 and 1151. So 1152 has never registered. So, but it has a certificate that says it's valid, and that's certificate 3. So that's the device 1152. So let's go ahead and in 1152, let's go ahead and just do a .NET run here. And this time, for whatever reason, the stars will align, and there's my found certificate, using certificate, and now you see it's provisioning and sending telemetry, just like we would have expected on the other one. And I'm not sure what happened on the other one, that it went wrong on me. So the good news is that you can do this very easily. The bad news is for whatever reason, I did something wrong in the demo live. But again, the most important pieces are the DPS ID scope, the certificates, and then the certificate password and this global device endpoint name. And then this is just sending telemetry. And the cool thing about this one is it has the device twins. So if I refresh here, see now 1152 is connected. It's actually running. So if I go here to the device twin and I tell it I want it to have a telemetry delay of 2, I can go ahead and save that. I'll send a device to cloud message. See right now it's reporting 1. If we go back to the output, we can see that we got an update telling it to set the telemetry delay. Oops, did I set the version and not the I set the version, not the telemetry delay. Okay, let's set that. All right, so there we go. So telemetry delay 2, version 3. So now if we go back to our device, we should get another, there's the original, there's the new update. Now, instead of going every second, the telemetry delay is going every 2 seconds. So we're able to force a device update through that device twin. So if I change this to, let's say 10 seconds, we can throttle our device a little bit in not sending telemetry so often. So you see now it's kind of a little bit slower on its telemetry push. So again, the nice thing about that device twin is it tells us the desired and the actual reported property. So you see it's reporting now that it's on version 4. It's saying telemetry delay 2 there, but it should say 10. Yeah, it does. Okay. Version 5, 10. It matches. Again, we can push this back to 1 second if we want, save that up, and then this will come back eventually with 6 and 1. Yeah. So it just allows us to quickly push those changes and be able to affect our device from that device twin. All right, so that's all I have for live demos today. You can rest easily. The rest of the stuff is just going to be quick talking, but there's a lot of stuff to cover yet. So I want to hit that up before we run out of time and make sure that you have a little bit more information to prepare yourself for the exam as we close up the day here. Okay, so this is what we just did. We made our devices. We used that device provisioning service as our bulk provisioning devices. And basically we've kind of seen this area. We have not done anything with the insights and reporting. And you will need to be responsible for understanding that ecosystem as, excuse me, as you take the exam. So Skill Me Up labs available that work through the stuff we just did. Getting started with Azure IoT again covers the overviews, connecting the IoT device, individual enrollment of devices in DPS, and automatic enrollment, which we just did. The X509 essentially was that lab, kind of in less detail. So the lab would obviously give you more information, walk you through it a little slower than I did, allow you to do that. So the next piece of the puzzle is the edge devices. So you saw me enroll an edge device just by saying edge enabled, but that really wasn't doing anything important. Edge devices are much more powerful than that. And so as you start working with edge devices, you're gonna need to know how to create one. You're gonna need to know how to deploy it. Deployment modules for the edge device and getting that out there, that's going to require specific pieces of information in the JSON and the manifest so that you have the deployment out there. We have labs to walk you through that. There's other ways you could read on that too. We're not going to do it today just to save time. It would take quite a bit of time to set up a container registry, push our own custom modules. We could set up a stream analytics job and push it out there and see all the routes, but it takes about an hour or two to walk through that. So it's just not feasible to walk through that live today, but just know that you'll want to be in command of those things. You want to be able to understand what it means to install the edge runtime on a device. So to make an edge device, it has to have the edge runtime. Define and implement the deployment manifest. So you'll need to understand the steps and the process of creating an edge module deployment and pushing that out to your edge module. You're going to want to be able to understand security and be able to push security modules to your edge devices, provisioning them with DPS, which is very similar to provisioning what we just saw, just edge devices. The edge automatic deployments then, deploying on constrained devices. So if there's network constraints, your protocols have to go through your networks. You can only do certain things to certain places if you don't have the right rights, just kind of understanding what you need to do to get your edge devices to work in those scenarios, securing your solutions and getting production certificates out into the wild to be used in your devices rather than these simple 1, 2, 3, 4 password certificates that we just saw. So be in command of creating and configuring edge modules, deploying an edge module to an edge device, being able to write your own module and publish that container to the Azure Container Registry, set that up as a manifest to be deployed to your edge device, being able to debug as you're developing these, selecting and deploying the appropriate gateway pattern so you understand how to set up the gateways to connect back to your IoT hub, implementing your module to module communication and your module to hub communication, and then also configuring offline storage. So you might want to push an Azure storage edge out to your device to store stuff on the local device rather than coming all the way back to the hub or to storage. So Lab 11 talks a little bit about this edge device deployment. You see here you have an edge device and you're going to deploy the module for stream analytics and basically write stuff to Azure storage while also being able to send your telemetry, your hot path back to the IoT hub. You also have the ability to create gateways. And so when we're doing these labs and these academic scenarios, you'll see that they would be done through the Ubuntu VMs. So you would just you create a VM at Azure, push the edge runtime, install it on the Ubuntu VM itself, and then connect it to the hub as an edge device. And so that's a good way to test and do this stuff and work through it and see how some of that stuff works. So Lab 12 kind of takes you through setting that up as a gateway. And then, there's other, modules and things you can read on Microsoft Learn as well. Processing and managing data then. So now we've got all of our devices connected. We've seen a little bit about device provisioning. We talked about IoT Edge. We didn't go into it in detail, just again, for time constraints and just the complexity of doing that isn't feasible for this talk. But you can do that. You'll understand it. It'll make sense. You need to do that. Make sure you're familiar with it. Then once you have all that, no matter which devices you're coming from, how are we going to work with our data in Azure? So now we're moving away from the things into the insights. And so here we're going to talk about things like message enrichment. So you want to be able to understand what it means to enrich messages, understand that it's free to enrich messages, but you can only do a certain number. You can create routing for those device messages. We saw, I clicked through earlier, a little bit and it said, here's where you're going to do your message enrichment. You can do routing queries so that you can then, determine based on the telemetry that's coming in where you're going to send it. So if it's, specific telemetry, you might send it to your hot path. If it's other telemetry, you might send it to your cold path. You might also only send partial telemetry data into your hot path and partial telemetry, and then the full telemetry to your cold path. The caveat to that is, as you do that, you might create duplicate data. So just be careful as you create these solutions to be aware of exactly what you're pushing where and how you can manage that data. You need to be able to integrate with Event Grid, which if you've worked with Azure at all, it's fairly straightforward. You set up messaging, you set up the event response to this thing happening. So it comes into the IoT hub, it does this, it triggers that function, this function triggers that thing, whatever you need to do through Event Grid. Azure Stream Analytics to basically process the streams coming in, again, similar to what you would do for an Azure Stream Analytics job on the IoT hub or on the Event Hub. You do the same thing on the IoT hub. And we're going to talk about inputs and outputs. Where's your input? Is it the IoT hub and your output is Azure storage? You can write data into Avro or JSON format into your storage, or you can basically just process that data and send information into Service Bus or Event Grid or to an Azure function. Stream analytics outputs, inputs, and queries are going to be a big deal. So make sure you're familiar with that process. And the next piece of the puzzle then is taking that same exact type of scenario and processing the stream on the edge. This is one of the labs. This is lab 10. It actually walks you through doing the different devices coming into your cloud gateway, but then using the time series insight on top of that for reporting. So time series insights allows you to do very nice business reporting on the data in some of those sliding windows, tumbling windows, hopping windows, whatever it might be, depending on what scenario you're trying to accomplish. And then I guess this is back to lab 11 again, just here again to see the stream analytics on the edge. So you could do the stream analytics here behind the cloud. So you would just go from a regular device to cloud stream analytics and then to storage or to Cosmos or whatever you want to do at that point. There's much more advanced scenarios than what's shown here. Or you can use that module and push it out to the edge. And once it's on the edge, then the stream analytics job is running here and sending the data to where it needs to go whether it be another storage module on the edge itself or a storage module at Azure or back to the hub or whatever it is, based on your queries, your inputs and your outputs. I wanted to show this because if you don't work through a few things, there's going to be some confusing things that you have to be aware of. And I recommend that you spend some time writing some of these inputs and outputs and these routes. So as we create manifests and deployments to the edge, you're going to be able to route your data. And so here we have route 1, which is telemetry to cloud. Notice the key points here. It's from some path, something that it's doing, and you write the code to write out data based on something. And here we might have temp sensor, TV11 or something, TP11, whatever you want to call it, temp sensor 11. And then this upstream. Upstream is the hub. So anytime you see $sign upstream, that's the hub. Now, you also want to be able to write from module to module. So here you see this is a brokered endpoint, and it's going, this is actually a hub, from the hub into your endpoint, and then telemetry to Azure Stream Analytics. And so this one's from the temp sensor into the endpoint, which is another module. So the really critical pieces of information here: writing to the hub, upstream; writing from the hub to your brokered endpoint; writing from module to module, from some path into some other brokered endpoint. So you see this is just one module to another module. And so different ways to write those different pieces of information. So here's just another image from one of the labs as well. This one's a little more involved. Here you can see you have just a regular device, not an IoT edge device. You have the cloud gateway, but you see that it has data going from the hub into the event hub as well. It also has Stream Analytics processing and going out to Power BI for your, for the actions that people are going to take. And then of course you have your warm path. So this is kind of more of a Lambda architecture where they're talking about a hot path and a warm path, or hot path, possibly a warm path, and a cold path. And so, Lambda doesn't have to be just warm and cold. It can be as many as you want, but just remember, the more complex you make your paths, the harder it will be to keep your data unique. If I'm sending the same data all three of these places, I now have triplicated my data instead of duplicated it, right? Excuse me. So we have labs on these as well: analyze message data in real time, IoT Hub integration with the event grid, introduction to Azure IoT Edge, and the create and deploy a custom edge module. So you can see how to do all those things. Again, if you sign up for one of our courses, you get access to these labs unlimited for 6 months. And then monitoring, troubleshooting, and optimizing. We're not going to spend a lot of time here because this is the same stuff that you've done hundreds of times in other things with Azure. You're talking about metrics, logs, analytics, log analytics, custom queries, dashboards, instrumenting your apps with code, policy definitions. So you can use policy definitions to enforce things on your scenarios as well. Maintenance communication. The really different piece here is probably the device twin properties and being able to validate those. So anything we saw earlier, we can write code to validate device twins. We can say, I want to make sure that my reported properties match what my expected are. And if they aren't, we can then trigger alerts or monitors or whatever we need to do. We have a lab on application performance and application insights if you want to dive more into that, but that's more of the .NET web area, but it does give you that familiarity with that solution type of architecture, reporting to application insights. So security, again, is an overarching concern at every piece of the puzzle, from the device out in the physical world to the services at Azure to the communication between the two. All of that has to be secure. So you need to, again, be familiar with security at Azure, how that works. Anything Azure AD, identity management, anything like that they could possibly throw you something curveballish, just to make sure that you understand how devices and services might communicate with each other, such as how does the IoT Hub and the Stream Analytics allow each other to communicate on the same network or same identity or whatever it might be. And again, that's mostly going to be configured through outputs, so it's not going to be as much identity, but you might see some stuff there. But the real thing here, how do we keep our devices secure? How do we make sure that we're checking to see if they're tampered? How do we deploy security modules out to the edge? How are we able to use certificates? How are we able to register them, use secure attestation, either through symmetric keys, X509 or TPM, using enrollments, Azure Defender for IoT. So if you create a standard hub, I didn't show this, but if you create a standard hub, you can turn on Azure Defender to make it more secure. And if you use the free version, the Defender is not available. So just keep that in mind. Security modules, again, are going to be important. You can push those out to your devices, and you can do that through deployments. And we saw a little bit of that if we were clicking on, either an IoT edge security module, or you might do just the regular modules to a regular device. Creating alerts when security things are happening. We have a lab on updating secrets from Key Vault, just to see how that might work as well. Working with Key Vault a little bit, but again, that's not really IoT specific at that point. And then finally, business management. So really the new hotness on business management, when you see this, you should think Power BI. And how do I get my data from my Azure services into Power BI, and how do I show things in a Power BI dashboard so that my business analysts can make the right decisions? So it's going to be all about input and output connections, whether that's from Stream Analytics or from storage or from whatever you're using to connect to your Power BI. You'll be able to make sure that you can present that data, build out a dashboard. And honestly, as an IoT developer, I don't think you have to be super awesome at Power BI dashboard building, but you should be aware that it uses tiles and you can put data onto the tiles. I just kind of be somewhat familiar with it so that you could make some logical decisions if you were asked to present a solution and a prototype or something with some of that data in a Power BI dashboard. Yeah. So again, there's third-party options as well. If you don't like Power BI or you don't have Dynamics 365 or Power BI or whatever MS 365 subscription is required, you might have a different thing that you're using, like Grafana or something, to build out some dashboards. Or you could just do it in an Azure dashboard or time series insight. There's just all kinds of options available to you. So the last piece of the puzzle here, I added this slide. This wasn't on the exam when I took the exam, so I'm not super 100%, 1000% familiar with the Azure Digital Twin solutions. But I did walk through one yesterday on Learn, just to familiarize myself with it enough to talk about it a little bit. What it comes down to is you're building a lot of JSON to configure your devices, and that's going to help you to set things up. So let me just show you quickly what that code somewhat looks like. And if you go out to the Azure IoT Central as well, when you're doing that, you're going to be doing a lot of stuff. But basically, with digital twins, the main pieces I got from the walkthrough I did yesterday, again, this is just academic level. I haven't done anything much with this other than walk through a Learn module. You create these interfaces in JSON. Notice that they have unique IDs. They have a type. They have a display name. They have this context. And then they have different contents, and ultimately they have these IDs, and then there's a ways to implement these different interfaces. So this is a factory floor interface, this is a factory interface, and then there's a production line interface. And this JSON and different syntax is just defining the structures that you want your devices to have. So those digital twins that we were seeing from our devices earlier gave us really simple data. This is basically defining the world in JSON. It's almost like the Matrix. If you really want to go to that level, you can write code that basically defines the physical structure of your entire ecosystem in JSON here. And by doing this, all my devices that are a production line device have to implement the production line interface, which means it has to have these properties and these enum values and these things. And so just be aware of all of this. So here's one that's implementing. You see this has got its own ID. This is the production step for grinding. This is a coffee thing. So they were doing grinding, molding, and roasting coffee. And so you have different step. This is a different step interface here that you have. And then, grinding was just going out there and doing that and extending the interface. So probably this is important, the extends piece. So you know where it came from. So this is a digital factory production step. And so if we go back to production step, I'm assuming that that kind of defines itself as a digital factory production step. So if I took that, I'm guessing, and went back to my production step grinding, it would look very similar here. Yeah, and so that's how it knows what its interface is implementing through that extends. So more of a Java syntax. If you're familiar with Java, that you'll like the word extends. Anyway, just has the contents then for that specific production step. This production step also extends the production step and has different contents here for different things that are defined. And again, all this comes down to is JSON to define digitally actual things that are going on my floor, on my production floor, on my in my ecosystem. And so that's what this DT document type definition language DTDL is for. They have a validator program that you can download. You download the program, you execute it against your different JSON, and it just tells you if anything doesn't look right. And then there's also a modeling program, which I don't have downloaded here, but you can do the modeling program. The modeling program lets you see the different steps. So if you want to learn more about that, this is a good segue into Microsoft Learn. So just about everything you need in learning new stuff for Microsoft anymore is going to be at Microsoft Learn. So you'll build your profile here. Let me see if I can sign in under my real account. Hold on a second. Actually, let's just go onto my other computer. It's already signed in. Except I don't have a browser open. Okay, so if I just go to Learn, so what I've done is I've created collections for all the exams that I'm taking and have taken. And so under my collections here, all I did was I went out to the Az-220 exam questions, just the documentation. And so at Azure, at Microsoft, and I went down to the online free. You see there's Introduction to Azure IoT, Connected IoT Devices, Intelligent Edge IoT Solutions, and now there's Develop with Azure Digital Twins, and you can see what I did yesterday. I completed all the other ones, but not this one. So you just add it to your collection. Once it's in your collection, you have your collections built. You can then go and look at your collections. And so here you see Azure Digital Twins. So yesterday I walked through this digital chocolate factory production line, which I guess I thought it was coffee is chocolate, I guess. But that's what I was showing you just a second ago with the DTDL, Digital Twins definition language. I didn't get to the rest of this stuff, but obviously I think if you're going to take the exam, I would walk through this stuff. It's new. It's just been added as of the 23rd, actually. So if you're taking the exam today or tomorrow, it may not be on there yet. But you can see that if you go out to the actual documentation to download, it'll tell you it's going to be updated on April 23rd, which is officially 2-3 days from now. And it'll be adding in down here at the bottom. It tells you this new stuff that's adding in. One of them is this section with the Azure Digital Twins. So yay for you, you get to take the Digital Twins piece. So you'll have to tell me how it went. But yeah, so that's the first step of learning. So anytime I'm going to take an exam, I go out, do as much of the modules as I have time for. Obviously, you know, like the AZ-303, which I'm going to take soon. I'm way behind where I want it to be, but you can see even like 9 hours, 5 hours, 7 hours, 4 hours, 8 hours, 6 hours, 6 hours, 3 hours. So there's what, 60 hours of stuff here? Oh yeah, 56 hours of learning that I can do just at Azure. Now, here's the thing I'm going to say, and these are great. These are awesome, and this gets you to a really great understanding of what's going on. But this stuff on the Learn is academic and it's high level. And so when you get to the exam, generally this isn't enough. It's a great start. It's a great, if you've never done this stuff, it's a great way to learn it. If you want to get more solid with information, it's a great way to learn it and go deeper. But I would recommend that this is not your only thing you do before taking an exam. You go through training with us or someone else. You work through the labs. So that's the next thing I want to show you. So let me just get out here back to the demo or to the PowerPoint for a second. So I want to just show you a couple additional resources that you take with you. First one is Learn. The second thing is Docs. So go through documents. The documents have a lot of the things that are in the labs, a lot of the things that are going to show up on the test. They'll have similar things, not as deep, but enough that it can help you. But if you're working through this in the real world, the docs also give you the syntax, solutions, and examples that you might need in order to quickly spin something up that is very similar to what you need, and you can tweak it. I always like to recommend 2 or 3 study guides, and generally you'll find me recommending Thomas Maurer every time. This guy's got some fantastic material, not only video-wise, but text-wise. So if you go out to his blog, he's got a link for the Az-220. Another great one is Hugo Barona. He has a great one for Az-220. And then Paul DiCarlo did one at Tech Community on Microsoft that I liked as well. And so check these out. These give you, again, a pretty good overview of what you need to study. Generally, they talk in detail, and most of these guys, as me as well, if you're walking through some of their stuff and you ask them a question, they would likely be not hesitant to answer. So again, Thomas Maurer he's an official cloud advocate for Microsoft, and so follow him if you're learning Azure. Trust me, you want to follow him. Anyway, some good links here. Again, what he does is he often takes you through the Learn modules and the docs, and so just a lot of really good stuff. A lot of really good stuff to study through. And then, yeah, so those 3. And then finally, I wanted to just point you to the labs that are available. We have these labs available in our live environment, which gives you free Azure subscriptions. And I've written most of them. The ones that we have available, I've rewritten them so that they're a little more user-friendly. These are built kind of in a way that expects you to have the same subscription and yeah, work through them in order and such. But you can see that there's quite a few labs out there. Before you take the exam, do the IoT Central. You really don't need the lab for this. Just go to IoT Central and just go out there and create a new app. So say I want to sign in or whatever, and build a solution, and then I'm going to go ahead and just create an app. So there's all kinds of different apps that they've got automatically out of the box for retail, energy, government, and healthcare. So let's say I needed to do continuous patient monitoring. I can just push create the app, put it into my account. I get it free for 7 days. If I want to keep it, I can then upgrade it. If I don't like it or if I don't want it anymore, I can get rid of it. If I know I'm going to keep it right away, I might, buy it right away. So that's basically what it is. Go ahead and create that. It provisions it out there. Again, the IoT Central is kind of in its own world. It is an IoT solution. It's deployable, but does it, here's my devices. So it built me a couple devices out of the box. These devices use templates. So if I go down here, you'll see there's templates for patches. They're very, very tedious to set up, to be quite frank, but you can get them set up with the different pieces of information you need. And then anything that wants to register has to map to these properties. And then you create dashboards around it. And then you publish the dashboard. And ultimately, once you get out there, then you start running it, you connect your devices, you look at your device and you see what it's doing on the dashboard as it's connected. You can see that data coming in. So obviously I'm not running any of my simulators yet, but you could create a simulated device, or you could get code to connect to this. Generally the lab for the truck one is the one that the lab is. It gives you the code that you need in order to dispatch your trucks, watch your truck temperatures as you're going around. Just be familiar with this before you take the exam. Don't skip over IoT Central. Make sure you're familiar with it. So I think that's just about it for everything. Hopefully you found this useful. Hopefully this time has given you enough of an overview and a taste of the IoT ecosystem to really dive in and take it to the next level. I encourage you to reach out if you have any questions. Connect with me at BL Gorman on Twitter, Brian L. Gorman on LinkedIn, or bgorman@appsagility.com via email. And I would love to hear from you as far as your journey. Leave comments under the YouTube, whatever you need to do. Ask questions if you get stuck. But yeah, there's so much to learn here, and it is quite a fun ecosystem. And honestly, I think we're going to see IoT as we move as developers in the next 5-10 years. Containers and IoT are going to be a big deal. I don't think we can get away from it. There's just going to be a lot of movement into these ecosystems. And even if you're doing traditional development, I think you want to be aware of them enough. So hopefully you're not, you're watching this. So if you made it this far, you definitely want to let me know that how you did on the exam, but you definitely wanted to be in this exam and in this study. So yeah, the IoT ecosystem is super fun. It's super easy to get started. Hopefully this gave you enough to do that. And if you have any more questions or get stuck on anything, please don't hesitate to reach out. I'd love to hear from you, and I wish you all the best. And hopefully you'll pass your exam and feel like a champion. And if you don't, take it again and pass your exam and feel like a champion. All right. Well, with that, I think I'm going to close it off for the day. I don't have any questions coming in, so I'm going to wrap it up. But hopefully everybody, again, found this useful, and we'll see you the next time. Thanks.